Chapter 6, Exponents. Student learning objectives are define exponents, simplify exponential expressions. An exponent is used as a way to abbreviate repeated multiplication. For example, we multiply 2 times 2 times 2 times 2 times 2 times 2. So 2 occurs as a factor 6 times. So we write it as 2 to the power of 6, where the exponent is the number of times that 2 occurs as a factor. And the factor itself is the base. So there are two parts to exponent notation, the base and the exponent. The base tells us what number is being multiplied. And the exponent tells us how many times the base is multiplied. When the base is negative, the result is positive for an even exponent and negative for an exponent, for an odd exponent. So let's evaluate here. 2 to the power of 3 is that we multiply 2 occurs as a factor 3 times. That means we multiply 2 times 2 times 2. This is equal to 2 times 2 is 4. So here 2 times 2 is 4, and then we have times 2. And this here is 4 times 2 is 8. 2 cubed is equal to 8. Now we have negative 2 times 4. So this means we're multiplying negative 2 times negative 2. So we can put it in parentheses, times negative 2 times negative 2. This product, we're multiplying negative 2 occurs as a factor 4 times. So negative 2 times negative 2 is 4 times negative 2 times negative 2. 4 times negative 2 is negative 8 times negative 2. So this times this is 4. This times this is negative 8. Negative 8 times negative 2 is 16. So this is what we meant here when the base is negative, which in this case the base is negative. The result is positive for even exponent. The exponent here is 4, which is even. So the result is positive. The positive is the 16. Negative 2 cubed. This here is equal to negative 2 times negative 2 times negative 2. We multiply negative 2 occurs as a factor 3 times. This here is equal to negative 2 times negative 2 is negative 4. And then times negative 2. Negative 2 times negative 2 is positive 4. 4 times negative 2 is negative 8. So our result is negative 8. And this is what we meant here. When the base is negative, the result is when is negative for an odd exponent. So 3 is odd, and the base is a negative 2. So we're multiplying negative 2 3 times to itself. The result is negative. So this is always the case in the case where we have a negative base and an odd exponent. Now, these expressions are not the same. Okay? In the first expression, the negative 2, the exponent 3 applies to this negative here. The 3 applies to that negative here. However, for the second case, the exponent 3 does not apply to the negative. So negative 2 in parentheses to the power of 3 is negative 2 times negative 2 times negative 2. Whereas this value here is negative 2 times 2 times 2. So this negative is the same as negative 1 times 2 times 2 times 2. So the answer, the result for this is negative 8. The result for this here is also negative 8. They just happen to be the same. Okay. So for example, if we have negative 2 to the power of 4, actually in this case, because they're odd, because they were odd, they're odd power, they're equal. But if they're even power, they're not equal. Okay. So the first one was did not illustrate what I wanted to say, but this example will illustrate that. So negative 2 to the power of 4. Okay, in this case, we have negative 2 times negative 2 times negative 2 times negative 2. This result is 16, positive 16, whereas the result here is negative 1 times 2 times 2 times 2 times 2. The result here, these are not equal. The result here is negative 16. Okay, so these two values are not equal. Now let's look at 9 to the power of 0. This is equal to 1.